Hi, I'm Assam, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 24, Question 66. And in this unit, we're going to take a look at two molecules, one that we're very familiar with, DNA, and the other that you're probably not so familiar with, PNA. They look pretty similar. DNA has a negatively charged phosphate backbone, and it obviously has these base groups that can form bonds with another DNA molecule, or in this instance, which have been shown, a PNA molecule, which also has these base groups. However, the big difference between DNA and PNA is that yes, DNA has this negatively charged phosphate backbone, whereas PNA has these functional groups or connected by peptide bonds. So these glycine functional groups, I think they call them N2 amino ethyl glycine molecules. And this functional group, if you want to call it, is neutrally charged. So there's no charge. So that's the big difference. So for all the biochemists out there who would have sat this exam, they would have seen this question straight away and said, well, DNA has a negatively charged phosphate backbone, therefore it's going to be a highly polar molecule, therefore it's going to be highly soluble in water. If you compare it to PNA, which has a neutral backbone, it's going to be less soluble. So that's why a lot of students would have saw this question straight away like that and said, okay, so 66, the answer has to be C, just by using some deductive reasoning. However, just be careful because the question does say that compared to a fragment of double-stranded DNA, the analogous fragment of double-stranded PNA. So we're looking at double-stranded PNA. It's not just one strand of PNA. So it's going to be another strand here, which is going to have the complementary base pairs. And you've got, say, your OH, so you've got your glycine group here. Just understand, I know in question D, option D, it says something about the base sequence. Because it's a double-stranded sequence, the bases here are shielded from the outside. So they're not going to have an effect on the solubility. So if it's in a double-stranded molecule, the base pairs aren't going to have an effect on solubility, again, because they're shielded. They're shielded by the functional groups on this side. Now, we need to also note that, yes, this question was simple, but in the GAMSAT, they might ask you questions similarly, I guess of the same nature, regarding the structure of DNA. You have to understand that the negatively charged phosphate backbone is important in research because we can use this functional property for gel electrophoresis. So for DNA products, after we do PCR to, I guess, amplify a signal, an RNA, a piece of genetic material. So we'd use gel electrophoresis because DNA has a negatively charged phosphate backbone, so it can travel through an agarose gel. Also, another piece of information that you probably might want to note is this is one I love asking students because they always say the same answer, but they always forget the real answer. So whenever I ask students, why is DNA more stable than RNA? I always get the answer from students, which correctly, yes, DNA is double-stranded, so therefore, and RNA is single-stranded, so it's obviously going to be a more stronger structure, therefore it's more stable. However, the correct answer, or the most correct answer is because, I mean, it's all in the name, DNA, RNA. DNA is deoxyribose nucleic acid. RNA, so D is deoxy. RNA, so deoxy. And this is just ribose. So deoxyribose. So if we say DNA versus RNA, so if it's deoxyribose, it doesn't have that hydroxyl group or the oxygen group on, I think it's the 2', I can't remember where it is in the structure, but the point is that this sugar lacks that oxy group, whereas in RNA, they have that group. And that makes RNA more susceptible to hydrolysis. That's why DNA is more structurally stronger than, that's why DNA, is more stronger than RNA because of the fact that it lacks this deoxy group. So it doesn't have this oxy group or this hydroxyl group, which makes it less susceptible to hydrolysis. So these are the sorts of things you should think about, not just when you answer this question, move on. Obviously in the exam, you just move on. But I'm saying if you're practicing at home, try to think about all the other possible questions that can ask you related to the structure of DNA, not just with PNA, but it could be RNA, and it could be other combinations. Now, if you're still having trouble with this unit, or I guess trying to understand the chemistry or the biology behind the structure of DNA or PNA, you can post your queries in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.